Okay, this question asks to determine if the geometric series converges. Okay, let's write it down. So it's 1 plus 1 over 5 plus 1 over 5 squared plus 1 over 5 cubed. So you can write this as k equals 0 to infinity, 1 over 5 to the k power. And this is our ratio, and ratio is less than 1, so we know it's converging, so it's not diverging for sure. So now let's find the value. So it's infinity a over 1 minus 1 r. A is the first term, and r is the ratio. Our first term is 1, so it's 1 over 1 minus, ratio is 1 over 5, so this is 1 minus 1 over 5, so 1 over 4 over 5, so this is 5 over 4. So the answer for this question is C. Okay, this question asks, determine if the telescoping series converges. So this is not actually in the telescoping series form, so we're gonna change it using the partial fraction decomposition. So this is 2 over m plus 1, m plus 3, right? This is equal to a over m plus 1 plus b over m plus 3. I'm assuming you know how to do partial fraction decomposition because that was the exam topic on the last exam. So I will skip the explanation. If you're still confused, go back to the partial fraction decomposition topics and study those. Okay, and then we're gonna multiply m plus 1 and m plus 3 on both sides. So this is gonna be 2a m plus 3 plus b m plus 1. So n is equal to negative 3, then 2 is equal to negative 2b, and b is negative 1, n equals negative 1. Then if you plug in the values, then 2 becomes 2a, and a is equal to 1. So our equation is 1 over m plus 1 minus 1 over m plus 3. So now let's plug it in the values. If n is equal to 1, this is 1 over 2 minus 1 over 4. If n is equal to 2, this is 1 over 3 minus 1 over 5. If n is equal to 3, this is 1 over 4 minus n 1 over 6. Sorry for the background noise, I can control them. N equals 4, then this is 1 over 5 minus 1 over 7. So this can be cancelled out. This can be cancelled out. And n equals 5. Let's try it one more. 1 over 6 minus 1 over 8. So do you see the pattern? So 1 over 4 cancelled out, 1 over 5 cancelled out, 1 over 6 cancelled out. Eventually 1 over 7 will be cancelled out, right? So all we left was 1 over 2 and 1 over 3. So if it goes to infinity, everything will be cancelled out, but 1 over 2 and 1 over 3. So this is 1 over 2 plus 1 over 3, which is 5 over 6. So the answer for this question actually converges to 5 over 6. Okay, this question asks which statement is true for the series 2 to the negative m over cosine m plus 2. Okay, let's try A first. A is asking comparison test. So, no, yeah, it's comparison test. Sorry, I thought I read the wrong one. Cosine m plus 2. And then we're going to compare it with 1 over 2m cosine m plus 2. Some might confuse why it's 1 over 2m, because 2 to the negative m is same as 1 over 2m, which is why I'm going to write it this way. And then, since it's this, which one is bigger? I guess this one is bigger, right? Because this is, suppose this is 1 over 2, and this is suppose 1 over 2 times 1 over 2. This is 1 over 4. So 1 over 2 is bigger than 1 over 4, right? So, which is why the, the equality symbol, or like the bigger symbol, goes that way. So if you're confused on like which one is bigger, just plug in the numbers and think which one is bigger, and then put the like direction. So we have that, and if you remember your comparison test, it's this one and that one, and cosine m is bounded by negative 1 to 1. So cosine m plus 2 would be 3 and negative 1. So this will be eventually just bounded between, oh sorry, it's not negative 1, plus 1. So this will be eventually just bounded by 1 over 1, 1 over cosine m plus 2, 1 over 3, and 1 over 3, and this symbol will be fixed like this. So it's bounded from 1 over 3 to 1, so this is not actually converging, right? So this will be diverging, right? And bigger one diverges, but if you remember your direct comparison test, it has to be small one diverging, then we know bigger one diverging. It's not the other way around, so this will be inconclusive for us. Right, it doesn't tell us anything. So let's try B. B is diverges m equals 1 to infinity 2 to negative m. This can be written as 1 over 2m, which is same as 1 over 2m. So this is actually, if you look at this one, this is going to be the ratio of 1 over 2, which is less than 1, so it's converging. Okay, now let's compare this m equals 1, infinity to negative m, and m equals 1, infinity to negative m, cosine m plus 2. So since this one is bigger, right? And we know that this one is bigger and this is bigger, converges. And if you know that bigger one is converging, then we also know the small one is converging. But it says diverges, so B is not right. And let's look at C. Converges by comparison test with 1 over cosine m plus 1. Okay, 1 over cosine m plus 2, sorry. And then 1 over 2 to the m cosine m plus 2. So we know that this one is diverging from the above example from A, right? So this is wrong. It's not even converging, it's diverging. So C is not right. D, we don't know because we have to check E first, right? So let's try E. So E is, it's basically the similar one as B, right? 1 over 2 to the m, and then 1 over 2 to the m cosine m plus 2. And we said this one is bigger. So it says bigger converges, if you remember from the B, right? Bigger converges. So small one also converges. So it is actually saying the right one. B converges by comparison test. So E is the right answer. If you don't remember your B, I can explain it again. So 1 over 2 to the m is convergent because of the geometric series. 1 over 2 to the m power, and the ratio is less than 1. So which means it converges. And 1 over 2 to the m is bigger than 1 over 2 to the m cosine m plus 2. So bigger one converges, then small one converges, which is why we can say that it converges. So the answer for this question is E. Okay, this question asks which of the series converges. Okay, let's look at the first one, 1 over 2k minus 1. And we are going to compare to 1 over 2k by direct comparison test. And 1 over 2k is divergent by p series because the exponent is 1, so this is divergent. And this one is bigger, right? So, and the divergent, a direct comparison test said small one has to be diverged in order to say bigger one diverge. And this is the small one, this is the bigger one. Small one diverge, so bigger one diverge. So it is divergent. So 1 is not right. 2 is negative 1 to k minus 1, 1 over k square root of k plus 1. Okay, so we're going to use alternative series test, and our AK would be 1 over square root of k plus 1. This is non-increasing, right? It's decreasing. If the k goes to infinity, it's getting smaller, right? It eventually goes to 0. So you can say that it's non-increasing. First condition is met. And the second condition was limit of AK has to go to 0. I mean, I kind of already showed, but I can show it again. 1 over infinity plus 1 is just same as 1 over infinity because 1 is very trivial number. So you can say it's just 1 over infinity. And this actually goes to 0. So this is right. So you can say that this is actually converging by the AST, alternative series test. So 2 is right. Let's look at the 3. 1 over k squared plus 1. So we can use the direct comparison test again. 1 over k squared. And then this one would be 1 over k squared would be bigger one, right? And then 1 over k squared, we can use p series test. And since p is greater than 1, because p series test said 1 over n to the p, and P has to be greater than 1 to converge, right? There's a weird thing always showing up, of course. P is greater than 1. So I'll just move in here so the 1 is still like that. Okay, P is greater than 1. And in our case, our P is 2. So 2 is actually greater than 1, so this one converges. And if you remember the direct comparison test, big one has to converge to say small one converges. Since 1 over k squared is bigger one and it converges, and then you can say the small one actually converges too. So 3 is also right. So the answer for this question is D. Okay, this question asks to find what is the smallest number n such that x minus xn is guaranteed by the alternative series estimation. So alternative series estimation said x minus xn is equal to xn plus 1, and we have to compare this value and this value, okay? So you can write 6 to negative 7 as 1 over 6 to the 7th power, and let's plug in n plus 1, xn plus 1, so n equals 1 to infinity negative n1 to the n plus 1 to the 7th power. That has to be equal to 1 over 6 to the n, so this has to be equal to each other, so n plus 1 to the 7th, and basically not equal to each other, but like it has to be less than or greater than to the 1 over 6 to the 7th power, so n plus 1 to the 7th power has to be greater, less than or n plus 1 to the 7th power has to be less than or equal to 6 to the 7th. 7 cancelled out, n plus 1 is 6, less than 6, so n is 5. So our answer is B. Okay, which of the following statements is false, more like? So let's look at option A. So n is equal to 1 to infinity n to the cube over Rn converges when R is less than, not less than, greater than or equal to 1, absolute value of R. So you can use ratio test or root test, whatever you want, but I'm going to use ratio test. So n plus 1 cube over Rn plus 1 divided by n cube divided by this original term, so which is flipping the reciprocal. So basically multiplying by the reciprocal, right? So this will be Rn over n cubed. This term will be just, if you go to infinity, this will be just 1, so you don't have to worry about this part. This is just Rn over Rn plus 1, and you can write Rn over Rn times R, and this will be cancelled out, so this is 1 over R. And in order to converge, this has to be less than 1, so 1 is actually greater than absolute value of R, so that is right. Okay, so let's look at option B. So this is the direct comparison test. Okay, AN and BN. So BN is the bigger one, AN is the small one. So AN is convergent, small one convergent, then bigger one convergent. This is not right, because if you remember the direct comparison test, it has to be bigger convergent, then you can tell small one is convergent. It's not the other way around, so this will be inconclusive. So that, oh, then we're done. But I'm going to prove the other ones too as well. So let's look at the C. So AN and BN. So BN is a bigger one, and AN is a smaller one. And it says small one is the divergent, so bigger one is divergent. That is right. If the small one is divergent, then you can say that bigger one is divergent. So this is right by the direct comparison test. And D, 1 over NP plus N is convergent. So you can also use direct comparison test for this one. So 1 over NP. And then if you remember your P series test, P has to be greater than 1 to converge. So that is right. Because if P is greater than 1, then this one will be convergent, and this one is actually bigger, so bigger one converges, and smaller one, then you can say converges. So this actually meets the direct comparison test and P series test. So D is right. And let's look at E. E is, so n equals 1 to infinity, R and N diverges for all R is greater than equal to 1. This is right, actually, because it's a geometric series. if you remember the geometric series, if r is less than 1, then you can say that it's convergent. So this ratio is greater and equal to 1, then it will be diverging. So that is also the right statement, which is why our answer choice B is the false statement. Okay, this question asks, which of the following series is the ratio test inconclusive? The ratio test is inconclusive when the ratio is equal to 1 or infinity or undefined. Okay, let's look at the first one. So n is equal to 101. Oh wow, that's a bigger number, but it doesn't really matter to us, right? En plus 1. So if you do the ratio test, limit n goes to infinity, this will be n plus 1 over en plus 1 divided by the original, so this will be reciprocal, and en plus 1 over n. This will just go to 1, because if it goes to infinity, by the L'Hopital's rule, this will be just 1. So this will be just limit n goes to infinity, en plus 1 over en plus 2. So this is just en times en times e squared. And this canceled out, so this is just 1 over e, which 1 over e is less than 1, so it is convergent. So it's not inconclusive, so 1 is not right. That means D is also not right. And E, oh, we don't know about E. Yeah, oh wait, none of them. Oh, we don't know. Yeah, we don't know about E, but we know for sure all of them is not right. So 2, let's look at that. N equals to 1 to infinity, negative 1 to the n, sine 9n over n squared. Using the ratio test again, this will be negative 1 n plus 1 sine 9n plus 1, 9n plus 1, because it's multiplied, 9 is multiplied in both, in like entire parenthesis n plus 1. So you can write that, and then n plus 1 squared. And then you divide it by the reciprocal and multiply by the reciprocal. So this will be negative 1 to the n sine 9n over n squared. This goes to infinity, then it will be just 1, so you don't have to worry about this part. Sine doesn't really matter because it's absolute value. So this is just sine 9n plus 9 over sine 9n, right? And if you remember your sine function, it's just this, right? So it's just going to infinity, and we don't know this value, so it's divergent or does not exist, because both of them is just infinity over infinity, which we don't know that value. So this is just undefined. So this will be inconclusive. So 2 is right. So 2a, b, c is not right then. Okay. Let's look at that. So e is also not right. So it's going to be either a or b, right? I shouldn't have circle both. But let's look at the third one. N equals 1 to infinity, 13n over 2 n squared. That's interesting. Okay. So let's adapt your lovely ratio test. 13n plus 1 over 2n plus 1 squared divided by and multiplied by the reciprocal, so 13n, 2n squared. So this will be 13n times 13n over 13n times 2n squared over 2n plus 1 squared, right? So this will be cancelled out, so 13 will be left. And this part, which we can do 13 times 2n squared minus n plus 1 squared. We can write that, right? Because it's just dividing the value, so we can write it as this format. So it's just algebra. So 13 times 2n squared minus n squared minus 2n minus 1. This cancelled out, so this will be 13 times 2, negative 2n minus 1, which is same as 13 over 2n plus 1. And if that is absolute value, I forgot to write a lot of absolute values. If I don't write it, just consider that there is absolute value, so don't forget that part. So if the limit n goes to infinity, 13 to 2n plus 1 will be 13 over infinity, which is 0, which is less than 1. So it is convergent. It is convergent. So the only right answer is then 2, which is B. Okay, this question asks for which values of c is convergent. Let's write it first. N equals 1 to infinity, 1 plus c squared over n to the nth power. So since we have the nth power, we can do the root test. Square root of n, 1 plus c squared over n time to the nth power. Nth power and the square root of n will be cancelled out. So this will be 1 plus c squared over n, but it is saying it's convergent, so it's less than 1. So c squared over n has to be less than 0, and then this will be just c squared is less than 0, so c is less than 0. And we don't see any option that shows that's the same, so it will be E, no values of c. Okay, this question asks to find the second order Taylor polynomial. Okay, if you remember your, Taylor series for cosine squared x, that would be great, but since I don't remember it, I'm just gonna manually find it. So our fx is cosine squared x. If you find the derivative of that, that will be 2 cosine x minus sine x, which is negative 2 cosine x sine x, and that looks kind of similar when we know that sine 2x is 2 sine x cosine x, right? So for simplicity, we can write this as negative 2 sine 2x. Okay, we have that, and then let's find the second derivative, which is negative 2 times 2 cosine 2x, right? So this becomes negative 4 cosine 2x. Okay, we have that. That's good. Oh wait, did I write it wrong? Oh, I did write it wrong. Sine 2x is 2 cosine of x, so this will be just negative sine 2x. Sorry. Right? Because 2 cosine x sine x is the same as sine 2x, so if you replace it, this just becomes negative sine 2x. And then I have to find the derivative again. My bad. So then this will be just negative 2 times cosine of 2x, so negative 2 cosine of 2x. We found the derivative. Now let's plug in that value at 0. So f of 0 of cosine squared 0 is just 1. F prime of 0, negative sine 0 is 0. F prime double prime of negative 2 cosine of 0 is negative 2. We have those values. That will be important because if you remember your Taylor series, it's basically f at some value plus a first derivative at value at a and then 1 prime plus f second derivative and then value at a 2 exclamation mark. Then the pattern goes on. So in our case, it will be f of 0 plus f prime of 0 over 1 exclamation mark and then f2 of 0 over 2 exclamation mark because we just want second order. So f of 0 is, what was it, 1. Cool, we have 1 plus 0 and, oh, I forgot to write the x minus a part. Yes, x minus a is also important. X minus a squared. Yeah, sorry, I'll just rewrite this equation. So when you want to find the Taylor series expansion or Taylor series Taylor polynomial, you have to write this equation fa plus f prime of a x minus a, don't forget that part, over one exclamation mark, and the second one will be f double derivative, second derivative of at a, and then x minus a squared over 2 exclamation mark, and then the third one will be f triple the third derivative at a x minus a cubed over 3 exclamation mark. But since we are only asked to find the second order, we are not going to worry about this part. So I'm going to erase it. We don't need it. So in our case, our a is 0. So this is f of 0 plus f prime of 0 x minus 0, right? Over 1 exclamation mark over, not over, plus f double prime of 0 x minus 0 squared over 2 and exclamation mark. And we know that f0 is 1. And then this is 1 plus 0 x 1 exclamation mark plus f double prime is negative 2. So negative 2 x squared over 2 exclamation mark. this is just 0, right? Because it's 0 over 1 exclamation mark. So 1 minus 2x squared over 2, which is 1 minus x squared. And what value do we have to plug it in for x? It's at pi over 6. So, oh, sorry, we don't need that. So 1 minus pi over 6 squared, right? Because we want to plug in x at pi over 6. So 1 minus pi over 6, 1 minus pi squared over 36. So the correct answer choice for that question is A. Okay, this question asks what is the remainder of the second order Taylor polynomial. So, okay, the remainder function is r of n, f m plus 1, c over m plus 1, exclamation mark, x minus a m plus 1. So in our case, we don't know the c, but we know that it's the second order, so n is equal to 2. So this becomes f to the third derivative of c, 3 exclamation mark, at x a is 1, so x minus 1 cube. Okay, we have everything almost. So this becomes f of x is 1 over x, which can be written as x minus 1. The derivative of that is negative x minus 2. The second derivative of that will be 2x minus 3. And the third derivative of that would be negative 6x minus 4. So it's the third derivative as 6, c, so negative 6 over c to the fourth power, so negative 6 to c to the fourth power, and then multiply by the 1 over 3 factorial, so 3 factorial and 6 cancelled out, because if you remember factorial, 3 factorial is the same as 3 times 2 times 1, which is 6, which is why you cancel out, and then add x minus 1 to the cube. So this is negative x minus 1 cube over c to the fourth power, and then our x is 1.1. So x is 1.1, so this is negative 1.1 minus 1 cube over c to the fourth power, so this is negative 0.1 cube over c to the fourth power. So the right answer for this question is A. Okay, this question asks to find the radius of convergence. Okay, let's write it. N equals 1 to infinity n squared x minus 2 to the m's power over m plus 1 to 3n's power. Okay, we are going to use the ratio test. So if you do that, this is m plus 1 squared x minus 2 m plus 2 over m plus 2 3m plus 1, and divided by the original, so which is the multiplied by the reciprocal. So this will be n plus 1 to the 3n power, n squared x minus 2 to the m power. And this all goes to limit of n goes to infinity. So n plus 1 squared and n squared, if it goes to infinity, this will be just 1. So we don't have to worry about this part. And same thing with n plus 1 and n plus 2. This, if it goes to infinity by the L'Hopital, this will be just 1. So you don't have to worry about this part. So all you have to worry about is this. I will not circle it. So the ones that are not circled. So you can write this as x minus 2n plus 1 over x minus 2n times 3n over 3n plus 1, which can be written as x minus 2 to the nth power times x minus 2 over x minus 2 to the nth power, and then times 3n over 3n times 3. So this term will be cancelled out, this term will be cancelled out. So this is eventually left with x minus 2 over 3. And we know that it has to be converging because it's asking the radius of convergence. So this is less than 1. Okay, we have that. So this will be x minus 2 less than 3. So x minus 2, 3 to negative 3. Add both sides by 2, so this becomes negative 1 to 5. So if it's just asking for the range, you can just say that, but it's asking the radius of convergence, so it's the end point minus the start point divided by 2 to find the radius of convergence. This will be 6 over 2, which is equal to 3. So the correct answer is C. Okay, this question asks to find the interval of convergence. Finally, okay. So n is equal to 1 to infinity, negative 1 to the nth power, x to the nth power over m plus 4. So it's using the ratio test. So -1 to n plus 1 x n plus 1 over n plus 5. And this is all happening in limit n goes to infinity and multiplied by the reciprocal. So this will be n plus 4 over -1 to the n and x to the nth power. This, the sign will be just, since it's an absolute value sign that we don't have to worry about. N plus 4 and n plus 5, if they go to infinity by the L'Hopital's rule, this will be just 1, so you don't have to worry about 2. So it will be just left with limit n goes to infinity, xn plus 1 over xn, which is same as xn times x over xn. Cancelled out. So this will be just absolute value of x, and since it's asking interval of convergence, it has to be less than 1. So this is x -1 to 1. So some might just like choose D for the answer because we have the interval, but this one doesn't include whether this one has to be included or not. So you have to actually plug in the values to see whether we have to include or not. So let's plug in the end point x equals -1. Equals -1. This becomes -1 to n power -n1 to n times n plus 4. So we're just basically plugging in the -1 in our original value. So this becomes -1 to 2n over n plus 4. So -1 to 2n shows that it's an even power. So this is just basically 1 over n plus 4. And then if you remember your what's that called? If you remember your p-series test, then this will be just 1 over n, right? I mean, we can, yeah, this is just 1 over n, right? So 1 over n is diverging, right? And basically, it's using the direct comparison test, but like 1 over n plus 4, and we're going to compare with 1 over n. And by the pure series test, this is p is 1 in our case, so it's diverging, right? So small one diverging, actually that's the bigger one diverging, sorry. No, this is bigger one, yeah. Bigger one, 1 over n, diverges, and then small one, we don't know it, right? Because it has to be small one diverging, then we know for sure bigger one diverge. But it doesn't matter for us, because whether it's diverging or inconclusive, we don't want to include it. That's one thing for sure. So this one is not included. So it will be -1 for the open parenthesis, which means it's going to be either C or D, not E, A, B, and A, not E, B, A. So let's just get the x equals 1. So this will be -1 to the nth power and times 1 to the n over n plus 4, which is same as -1 to the nth power over n plus 4. So if you remember, in this case, since the sign is alternating, we can use AST, alternate series test. So if you plug in 1 over n plus 4, limit of n goes to infinity, this will be 1 over infinity, which is 0. So the first condition is met. Second condition is non-increasing. So 1 over n plus 4, if n goes to infinity, this gets smaller, right? This is just logically makes sense. If you plug in n equals 1, then it's 1 over 5. If you plug in n equals 2, this is 1 over 6. It just gets smaller. So this is also making sense. So by the AST, you can say that it's converging. So you include this point. So it will be -1, 1, and close bracket. So this is option C.